Welcome to the first in a series of short introductory videos on the atom and atomic structure. In this series, we'll look at how the theory of the atom was developed, how its structure was elucidated, how that led to the construction of the periodic table, and ultimately how the periodic table can be used to determine reactivity. This series is meant to be an introduction to the much deeper understanding and study of the atom and chemistry. 2,500 years ago in ancient Greece, Hippias of Miletus first came up with the idea that materials could be broken down into tiny individual particles. His student, Democritus, came up with the name atom for them. Atom is basically a Greek word meaning something that is indivisible. Over the years, the atomic theory was just one of many theories on what stuff is actually made up of. Over the next several millennia, people had worked with materials. They had noticed that you could dig different things out of the ground and that you could refine them and that you can combine them in other ways to make new things. But there was no consensus on actually what stuff was made of. Things started happening very quickly in the 19th century. At that point, the instruments available to observe nature had reached the point where they were able to aid man's inquisitiveness in questioning nature. Robert Dalton in 1803 was the first one to note that you could have different elements or atoms of different material would combine to form new materials, but when they combined, they would always combine in exact ratios. This law of multiple proportions was the first inclination that not only did atoms exist, but that different atoms existed having different properties. In 1869, Dmitri Mendeleev refined this even further by coming up with the first idea of the periodic table. He noticed that different pure materials behaved differently and had predictable, not only did each material have predictable properties, but that these actually came into groups where materials could be clumped together or grouped together and they would behave similarly. This was the first attempt at a periodic table. Time continued 19th century, and things really began to advance rather quickly. By the end of the century, J.J. Thomson had discovered the cathode ray. Besides giving things like television and X-ray machines and other useful materials, Thomson essentially found out that there were particles in nature that were separable and had a negative charge that could be separated from the main bulk of materials. This came further when Wilhelm Wien, in 1898, discovered that there were also positive rays that could be developed, and that there were positive particles that could be extracted from matter. Of about 2,500 years. We started with ancient Greece postulating but not proving that something called an atom existed. This thing would be small. The Greeks said that they were all uniform and that they couldn't be divided. Throughout history, people had been using materials and developing new materials on an ad hoc basis. It took about 200 years ago when people realized that this could be systematized. Atoms did exist, but they were not the smallest things around. Different elements existed. The atom of each element had unique properties that was different from an atom of other elements. Finally, only 100 years ago, people found out that the atom indeed could be divided. You had the familiar classifications that we know now, that atoms are made of electrons, protons, and neutrons. with the electrons having a negative charge, the protons having a positive charge, and the neutrons having no charge. Protons and neutrons are also known to contribute most of the mass of nature. The interesting thing, even 100 years ago, nobody was actually sure how these particles were put together and what made one atom different from the other, and different elements. Essentially, for the most part, people figured reasonably that if protons were positive, neutrons were zero, and electrons were negative, positives and negatives attracted to each other. So everybody just generally assumed that all these particles would be clumped together, essentially forming big lumps of matter that in essence resembled a raisin bread or a blueberry muffin, where you just have negative electrons stuck on a positive center. This view, while it made sense, was actually, as we know now, completely incorrect. In future videos in this series linked below, we'll see how people determined that this was not the correct structure for the atom, and what the correct structure of the atom actually did look like, how that was determined, and how that determination has led to the greater understanding of chemistry and chemical reactions that we have to this day. So thank you very much for listening, and I hope you enjoyed this and will find these videos useful.